we are going to start now the lecture 4 of chapter 10 class 9th mathematics circles. So in this lecture we will talk about the results related to cyclic quadrilaterals. So cyclic quadrilateral is a quadrilateral all of whose vertices they lie on a circle. So if ABCD is a quadrilateral, we say there is a circle which passes through all the points A, B, C and D. The first result that we have to prove is that the opposite angles of a cyclic quadrilateral, the sum of opposite angle of a cyclic quadrilateral is 180 degrees. So what we have to prove is that the sum of angle A and angle C and sum of angle B and angle D in these two quadrilaterals, the sum of these two angles and sum of these two angles, it is 180 degrees. So to prove this, we are going to do the construction over here that we have joined A, C and B, D. Now look at this arc A, B over here. On this arc we have two angles. One is the angle ACB and second is the angle ADD. We are talking about these two angles over here. So both these are on the arc AB. It means this angle at D, if its value is x, then the value of this angle at C is also x. Similarly, look at these values over this arc over here, BC. For this BC, we are having CAB, and second we are having BDC. And both these angles over here, this angle we are saying it is y, and this angle we are saying it is y. So we are talking about two equations over here. One is that these two angles these are equal, and second we are saying these two angles these are equal. These two equations these are mentioned over here. These are the two equations that are mentioned over here. Now suppose the value of this third angle we are talking over here, this third angle at this angle at B, suppose its value is z. Now what we have is in this triangle ABC I am talking about. In this triangle ABC we are having this angle is y, this angle is x and this angle is z. So what result we are getting is that x plus y plus z equal to 180 degree. Now what is this x plus y? What is this value x plus y? It is angle ADC. What is this angle z? This is angle ABC and that is equal to 180 degree, and this is what we have to prove. Now the sum of all the angles of the quadrilateral, if we are talking about this quadrilateral ABCD, the sum of all the angles of this quadrilateral is 360 degree. The sum of angles at D and B is 180 degree. It means the sum of the angles at A and C will be 180 degrees, and this is what we have to prove. Now the next result is the converse of the previous theorem, and it says that if the opposite pair of the quadrilateral, the sum of the opposite pair of the angles of the quadrilateral, it is 180 degree, then the quadrilateral is cyclic. So we are considering a quadrilateral ABCD, and we are saying that the sum of the opposite pair means we are talking about this angle at B and this angle at D. The sum of these two angles, their sum is 180 degrees. So we have to prove that this quadrilateral is cyclic quadrilateral. So first we consider that suppose this quadrilateral is not a cyclic quadrilateral, then we are talking about, we are going to do the construction over here, and we have constructed a circle passing through the points A, B and C. We are considering these 3 points A, B, C, and we have drawn a circle passing through these 3 points. We have considered that it is not a cyclic quadrilateral. It means that point D will not lie on the circle, otherwise the theorem will be complete. So there are two cases, either the point D will lie outside the circle or the point D will lie inside the circle. If the point D is lying outside the circle, we are saying this circle is intersecting this line CD at the point D dash, and if the point D is lying inside the circle, we have extended this line CD, and we are saying that this extended line is intersecting the circle at the point D dash. Now look at this quadrilateral over here, A B C D dash. This A B C D dash, this is a cyclic quadrilateral, and if it is a cyclic quadrilateral, then from our previous result, suppose the value of this angle is x, value of this angle is y, value of this angle is z. So we are saying the value of this angle is y dash and value of this angle is z dash. Now what is given to us is that the sum of these two angles is 180 degree. So we are saying x plus z dash equal to 180 degree. This is given. In this case, x plus y is 180 degree. This is given. Now if A, B, C, D dash is cyclic quadrilateral, then in this case we will have x plus y dash is 180 degree. If we subtract these two equations, what we get is this gets cancelled, and we get z dash is equal to y dash. Similarly, in this equation, we are talking in this second case, we are saying that x plus z is equal to 180 degree because it is cyclic quadrilateral. We subtract these values, we get y is equal to, we subtract these equations, we get y is equal to z. So what we are saying is these two angles, these are equal. In this case also these two angles, these are equal. So if we look at the triangle, in first case we are talking about A D dash D, this triangle we are talking about, y dash is the exterior angle, it is equal to interior opposite angle, and this thing is not possible. Similarly, if we look at this second triangle A D D dash, we are saying y is the exterior angle, z is the interior opposite angle. These two angles cannot be equal. So where the problem is lying is, the problem is lying in our supposition that A, B, C, D is not cyclic. So it means our supposition that A, B, C, D is not cyclic is wrong. So we have, what we should have is that A, B, C, D should be a cyclic quadrilateral, and this is what we have to prove. Now the next theorem that we have to prove is, that is called the exterior angle property of a cyclic quadrilateral. So in this we are saying that if one side of a cyclic quadrilateral is produced, we are saying A, B, C, D is a cyclic quadrilateral, and this side A, B of the cyclic quadrilateral is produced, then the exterior angle so formed is equal to the interior opposite angle. So we are saying this is the exterior angle formed at B. We have to prove that it is equal to the angle D. Suppose the value of this angle at D is x degree. ABCD is a cyclic quadrilateral. It means this angle at B over here, this is 180 degree minus x. Then the angle at B over here, we are saying ABE is a straight line. So these two form a linear pair, these two angles form a linear pair. So the value of this angle will be 180 minus 180 minus x, that is equal to 180 minus 180 plus x, that is equal to x degrees. So what we get is both these angles, these are equal to each other. So we have proved three theorems over here. The first we have proved is the opposite angles of a cyclic quadrilateral are supplementary. Second, if a pair of opposite angle of a cyclic quadrilateral are supplementary, then the quadrilaterals are cyclic. And third is the exterior angle of a cyclic quadrilateral, the angle formed by producing a side, we are getting the exterior angle, and that angle is equal to the interior opposite angle. In this question we are given a cyclic quadrilateral ABCD, and it is given that these two sides AB and DC, these are parallel to each other. So if this is a cyclic quadrilateral, this angle is 100 degrees. The value of this angle will be 180 minus 100, because sum of opposite angles of a cyclic quadrilateral is 180 degree. So we get that the value of this angle is 80 degrees. Now we are talking about two parallel lines. One is this line AB and second is this line CD. We are talking about the transversal BC over here. This is the transversal over here. So if this is the transversal, then the sum of these two angles should be 180 degree. It means the value of this angle will be 180 minus 80 is equal to 100 degree. Similarly, we are saying this is the transversal over here. If this angle is 100 degree, then the value of this angle will be 180 minus 100 is equal to 80 degrees. So these are the four angles. These are the three angles that we have to calculate. That the value of BCD is 80, ADC is 80, and ABC is 100 degrees. Now next, in this given figure, we have to calculate the values of X and Y. So again, ABCD is a cyclic quadrilateral. So what we will have is that the sum of the opposite angles will be 180 degree. Opposite angle means if we are looking at the angle at A, it is 2x plus 4 degree. This is 4y minus 4 degree. So sum of both these angles, 2x plus 4 plus 4x minus 4. The sum of both these angles is 180 degree. Similarly, this angle at B is x plus 10 degree. This angle at D is 5y plus 5 degree. These are the two angles we are talking about. The sum of both these angles is 180 degrees. So the two equations that we get from this, these two equations, we are getting these two equations. First we solve this, you will get it is 2x plus 4y is 180. Second, you will get x plus 5y is 165 degrees. We have divided this equation with 2 and we get x plus 2y is equal to 90 and x plus 5y is equal to 165. So we have to solve this equation. Solve this equation means we are talking about x plus 2y is equal to 90 and x plus 5y is equal to 165. So if we subtract these two equations, we will get minus 3y, that is equal to 165 minus 90, that is equal to minus 75 degrees. So the value of y we will get it is 25. Now putting the value of y in, suppose first equation, we are getting x plus 2 into 25 is equal to 90. So we get x is equal to 90 minus 50, that is equal to 40 degrees. So the values of these angles, by substituting the values of x and y, we will get the values of these angles, and the values that we are getting, they are value of A is 84 degree, value of B is 50 degree, value of C is 96 degree, and value of D that we are getting, it is 130 degrees. Now in this next question, it is given that this AOD is the diameter. If AOD is the diameter, then angle ACB, this will be 90 degrees. Now the angle at D is given to be 130 and ABCD, you look at this quadrilateral ABCD, its vertices, they lie on the circle. So it means it is a cyclic quadrilateral. So the angle at B will be 180 minus 130, that is equal to 50 degrees. Now look at this triangle ABC. Look at this triangle ABC. We have this angle is 90 degree, this angle is 50 degree. So the value of angle at X will be 90 minus 50 is equal to 40 degrees. This is the value of x that we have. Next, a circle is given to us with the center O. O is the center of this circle, and it is given that angle AOC is 140 degrees. We have to find the value of angle ABC. So to find this angle, we are going to do the construction over here, and we have on this arc AC we are talking about. We are talking about this arc AC. This angle is 140 degree. We have considered a point D on this circle, and we have joined AD and DC. Then the value of this angle at D will be 140 by 2, that is equal to 70 degree. This is the angle at the center. So angle on the circle will be 70 degree. Now look at this figure over here, ABCD. This is a quadrilateral we have, cyclic quadrilateral, because all the points ABCD they lie on the circle. So we are saying that the sum of the angles at D and B will be 180 degree. So the angle at B will be 180 minus 70 is equal to 110 degrees, and this is the value of the angle ABC. Now next we are given this circle is given, and O is the center of this circle. This point O is the center of this circle. It is given that angle AOC, this angle over here, this is 110 degrees. We have to calculate the value of this angle at B. How this B is formed? We are saying AB is produced to BD, and this angle CBD we have to calculate. So what we are going to do is we are going to do the construction over here. We have considered a point E on this circle, and we are joining this point A and E, C and E. We are joining these points. So now look at this arc ABC over here. The angle at the center is 110 degree. Then the angle at this point E will be 110 by 2, that is equal to 55 degrees. Now look at this angle at B over here. Look at this angle at B over here. This is the exterior angle of the quadrilateral, and the interior opposite angle to this angle B is this angle E. So the value of this angle will be 55 degrees, because the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now in this question we are given a cyclic quadrilateral ABCD, and its diagonal they intersect at the point E. This is the point E that is given to us. Now the angle at this angle at B is given to be 70 degree, and this angle at A is given to be 30 degree. We have to find the angle BCD. Further, it is given that this AB and BC length, these are equal. So if these two lengths these are equal to each other, then we are saying that ABC triangle we are talking about, these two lengths these are equal to each other. Then if this angle is 30 degree, then this angle is also 30 degree. Now look at the arc CD. This arc CD we are talking about. Look at this arc over here. On this arc we are having the angle this BC, and the value of this angle is 70 degree. On the same arc we are having the angle over here CAD. So it means the value of this angle is also 70 degrees. Similarly, if we look at the arc BC over here, on BC we are saying the angle BAC and angle BDC, they will be equal. So angle BDC will be, this angle BDC will be 30 degree. Now look at the triangle BDC. This triangle we are talking about. This angle is 70 degree. This angle is 30 degrees. So the complete angle at C over here, this angle at C over here, it will be 180 minus 70 minus 30, that is equal to 80 degrees. Now the angle that we have to calculate, it is angle ECD. Then the value of this smaller angle will be 80 minus 30 is equal to 50 degrees, and this is what we have to calculate. In this question we are given an isosceles triangle ABC, and it is given that the side AB and AC, these two sides, these are equal to each other, and a circle is passing through the points BC, intersects the side AB at D, this point D, and AC at the point E. We have to prove that this DE is parallel to BC. So if AB and AC, these two are equal, so we have this angle is x, then this angle is also x degrees. Now look at this cyclic quadrilateral BCED. We are talking about this quadrilateral BCED, this quadrilateral. This BD side is extended in this direction, it is DA, and we are saying that this is the exterior angle over here, and exterior angle x, that is equal to the interior opposite angle for a cyclic quadrilateral. We know this property. So this angle at D is also equal to x. Now look at these two lines over here. One is this line BC and one is this line DE. For these two lines we are saying this AB is the transversal. These two angles, these are equal. These are the corresponding angle and these are equal. And if corresponding angles are equal, it means we have these two lines DE and BC, these are parallel to each other. Now in this question we are given a parallelogram ABCD. This ABCD is a parallelogram. Parallelogram means these sides, these are parallel to each other. Then through ABC we have constructed a circle, and this CD extended over here. This circle meets at the point E over here. We have to prove that AD and AE, these are equal in length. So to prove these are equal in length, basically we have to prove that this angle at D and this angle at E, these two angles, these are equal to each other. Now ABCE is a cyclic quadrilateral. So sum of the angle ABC and this angle, the sum of these two angles will be 180 degree. So if the angle at B, the value of this angle at B is y, then the value of this angle at E, it is 180 minus y. Now this ABCD is a parallelogram, so it means that this angle at D, this is also equal to y, that is equal to the opposite angle over here. This angle is also y. So this angle at D, this angle at D, the value of this angle will be 180 minus y. So what we have now is that the angle at E and angle at D, both these angles, these are 180 degree minus y, that is both these angles, these are equal. So we have these sides AE and AD, both these sides, these are equal in length, and this is what we have to prove, that AD is equal to AE. Now in this next question we are given a cyclic quadrilateral ABCD, we are talking about, and angle at A and B are given to us. Then we have to find the values of these angles at P and Q. So if we look at this quadrilateral, then this side AD is extended over here to DP, and the angle at this point CDP we are talking about. For this angle at B, this is the interior opposite angle, so the value of this angle is 80 degrees. Next we are talking about that the side BC of this quadrilateral, we are looking at this side BC, or this quadrilateral is extended to CP. So for this angle at C, this angle 60 degrees is the interior opposite angle, so the value of this angle is 60 degrees. Now in this triangle BPC, we have this angle P is 180 minus 80 minus 60, that is equal to 40 degrees. Now corresponding to this angle at 60 degree, we have this angle over here. This is the these two lines we are talking about. This is DQ and BP. These are intersecting over here. So this angle is 60. Then this angle over here, it is also of measure 60 degree. Next, if this angle is 80 degree, then the measure of this angle is 100 degrees. Again, in this triangle, the triangle CBQ we are talking about, the measure of the angle Q will be 180 minus 100 minus 60. So that will be equal to 20 degrees. So these are the two angles. This is the 40 degree value and this is the 20 degree value. These are the two angles that we have to calculate in this question. Now in this question, we are given the cyclic quadrilateral. It is PQRS. This is the cyclic quadrilateral given to us. And at P, the angle bisector is there. This angle bisector at P is given. This is the angle bisector at P. And angle bisector of this R is given. This is the angle bisector of R. This angle bisector of R intersects this circle at point B, and angle bisector of this P intersect this circle at the point A. Now we have to prove that this AB, this line AB is the diameter of the circle. We have joined these points A and B and we have to prove that it is the diameter of the circle. So the construction we are going to do over here, it is, we have joined the points P and B and we have joined the point B and S. So as PQRS is a cyclic quadrilateral, so we have the angle at this P, this whole angle at P over here, plus this angle at R over here, this whole angle at R over here. The sum of these two angles will be 180 degree. We are talking about if this angle is X and this angle is Y, sum of these two angles X plus Y, that is equal to 180 degree. Now PA is the angle bisector. It means the value of this angle is X by 2. The value of this angle is X by 2. Similarly, the value of this angle is Y by 2 and the value of this angle is Y by 2. So what we get is that X by 2 plus Y by 2, that is equal to 90 degrees. Now look at these angles over here. We are talking about this angle QPA. This is on the arc AB. QA. This is on the arc QA. Similarly, if we look at this arc over here, we are talking about this angle SPA and we are talking about this arc AS. On this arc AS, we are having this angle is X by 2. So on the same arc, we are having this angle at B over here. So value of this angle is X by 2. Now, if we look at the arc BS, we are talking about this arc BS over here. So on this arc, we are having one angle is this, that is SPB. And on the same arc, we are having this angle BRS, whose value is Y by 2. It means this angle at P over here, this angle at P over here, its value is Y by 2. This angle we have, its value is y by 2. So the total angle we have over here, this angle, this total angle over here, its value we have, it is 90 degrees. And if the value of this angle is 90 degree, this angle is on this arc AB. This angle we are talking about, this angle BPA. This angle is on the arc ASB. So this thing proves, and this angle is 90 degree. It means this thing proves that this AB over here, this is the diameter of the circle, and this is what we have to prove. Next we are given that a circle is there and AC is the, this AC is the diameter of the circle with the center O. This is the center O of the circle. We are saying if CD, this CD is parallel to BE, if CE is parallel to BE, angle AOB, this angle AOB we are talking about, this is 80 degree, and angle ACE, this angle ACE, this is 10 degrees. Then find angle, the angles that we have to find is angle BEC, this angle over here, this we have to calculate. Then angle BCD we have to calculate, this angle, and we have to calculate the angle CED. This is the third angle that we have to calculate. Now we are saying that AOC, it is the diameter, so it is a straight line. So we get that if the angle AOB is 80 degree, then the remaining angle over here, this angle is of measure 100 degree. Now we are saying that the arc BC we are talking about, this arc BC we are talking about, this is making an angle of 100 degree at the center. So this arc also makes an angle at this point E over here. So the angle at E that we will get, it will be 50 degree, that is half of the angle at center. Similarly, if we look at this arc AB over here, this arc AB at the center, it is making an angle of 80 degree. Then at the point C, this will make the angle of, this is at the point C, it will make an angle of 40 degrees. Now we are given that the lines EB, we are talking about this EB, and this line DC, these two lines, these are parallel to each other, and this line EC is the transversal. If this line is the transversal, it means this remaining, this angle over here, its measure will be 50 degree, that is angle ECD we are talking about, its measure is 50 degree. So the angle of the, this measure of this whole angle we are talking about, the measure of this whole angle will be 50 plus 10 plus 40, that is equal to 100 degrees. The measure of this whole angle will be, this whole angle, the measure of this whole angle will be 100 degrees. Now what we have is this whole angle over here, we have measured that this angle is 100 degrees. So the measure of this opposite angle, because EBCD, it is a cyclic quadrilateral, so measure of this angle will be 180 minus 100, that is equal to 80 degrees. The measure of this angle we have calculated, it is 50 degree. So measure of this remaining angle will be 80 minus 50, that is equal to 30 degrees. So these are the angles that we have to calculate. This measure is 30 degree, this is 100 degree, and this angle we have calculated, its measure is 50 degrees. Now next we are given a triangle ABC. This ABC triangle is given to us, and it is given that this side AB and this side AC, these both sides, these are equal in length. This triangle is isosceles. ABC is an isosceles triangle, and this AB is equal to AC, and angle ABC, the measure of this angle over here, it is 50 degrees. We have to find the value of the angle BDC and angle BEC. Now as these two sides AB and AC, they are equal, so angle at B is 50, then angle of over here at C is also 50 degree, and ABC is a triangle, so it means this angle over here, this will be 180 minus 50 minus 50, that is equal to 80 degrees. This angle at A will be 80 degrees. Now if we look at this arc BC over here, then on this arc we have this angle at A and we have this angle at D. So measure of this angle at D is, this measure of this angle D is also 80 degrees. And as these quadrilaterals we are talking about, ABEC you can say, or DBEC CD you can say, both these quadrilaterals, these are cyclic quadrilaterals. So sum of the angles, this angle at A and angle at E, sum of both these angles, we are saying sum of both these angles will be 180 degree. So measure of this angle will be 100 minus 80, that is equal to 100 degrees. So these are the two angles that we have to calculate. This is 80 degree and this is 100 degrees. Next, the figure is given to us, and it is given that this AOB is the diameter of the circle with center at O. We have to write the numerical value for the angle ACD, this angle, plus angle DEB, this angle over here. So to find the sum of these two angles, we have done the construction over here, and the construction is that we have joined B and C. So when we joined B and C, we have this angle ACB over here, this ACB, this angle will be the angle in the semicircle. So the value of this angle will be 90 degrees. Now if we look at the quadrilateral BEDC, this is BEDC, we are talking about this quadrilateral over here, then we are saying that angle BCD, this is our angle BCD, plus angle DEB and this angle we are talking about, the sum of these two angles, that will be 180 degree. So the equation that we will have, it is that angle BCD plus angle DEB, that is equal to 180 degree. If we add 90 degree, or we are saying that we are adding ACB angle, it is angle BCD plus angle ACB plus angle DEB is equal to 180 plus angle ACB. Now what is the value of angle ACB? It is 90 degree. So this total value over here, this will become 270 degree. And what is this angle? It is BCD, this angle, plus this angle ACB. So the value of this whole value will be equal to angle ACD plus angle DEB, and sum of both these values will be 270 degree. Next we are given that this AB is the diameter of the circle. This AOB we are talking about, this is the diameter of the circle, and CD is parallel to AB. These two are parallel to each other. Then this angle at A is given to be 25 degrees, If this angle is 25 degrees and this AB is the diameter, then this angle at D, this will be 90 degree, because it is the angle in the semicircle. This angle at D over here, this will be 90 degrees. Now if we look at this triangle ABD, we are talking about this triangle over here, then this angle at B will be 90 minus 25, and that angle will be 65 degrees. Now this quadrilateral is a cyclic quadrilateral. This angle is, we are talking about this quadrilateral ABDC, and this angle we have it is 65 degrees. Then the measure of this angle at C, this will be 180 minus 65, that is equal to 115 degrees. Now these two lines, this line AB and this line CED, these two lines, these are parallel to each other, and this AC is the transversal over here. So what we have is that the sum of these two angles, this angle and this angle at A, sum of these two angles should be 180 degree. So what we get is that the measure of this whole angle A, it is 180 minus 115 degrees. Now measure of this angle is 25 degrees. So the angle that we have to measure is CAD. So the measure of this angle CAD over here, the measure of this angle will be 180 minus 115 minus 25, that is equal to 40 degrees. Measure of this angle is 40 degrees. Next we are given that AB is the diameter of the circle. This AB is the diameter of the circle, and this line CED and AB, these are parallel to each other. These two lines, these we are saying these are parallel to each other. Now it is given that the angle BAC is 20 degrees. This angle is given to be 20 degrees. We have to find the value of BOC. So if we look at this arc over here, BC arc, we are saying this angle is made at A and this is made at the center. So the value of this angle will be 40 degree. Now next we are saying that these two lines CD and AB, these are parallel to each other, and OC is the transversal for these two lines. So if this angle is 40 degree, then we get that this angle over here, this whole angle is also 40 degree. Now OC and OD, these both are the radius of the circle, so they are equal in length. So if we look at this triangle over here, OCD we are talking about, and this angle is 40 degree at C, then the angle at D will also be equal to 40 degree. We are saying this angle is 40 degree, this angle at C is 40 degree, this angle at O is 40 degree. So now look at this triangle OCD. Now in this triangle we are saying this whole angle will be 180 minus 40 minus 40, that is equal to 100 degrees. So this angle COD will be 100 degrees. Next we have to calculate the angle CAD. Now this angle COD, this is on the arc CD, this arc CD we are talking about. This COD angle is on this arc. So on the circle we are having the angle CAD. So this angle at CAD will be half of this angle. This angle over here, this will be half of 100, that is equal to 50 degrees. So this total angle over here, we have it is 70 degrees. Now again look at the two lines, one is this line CD and one is this line AB we are talking about. For these two lines we are saying this AD is the transversal line. This angle, this total angle at A is 70 degrees. So angle at this D will be, this angle at D will be 180 minus 70 is equal to 110 degrees. So these are the angles that we have to calculate. Now next in this figure, A, B, C, D is a cyclic quadrilateral that is given to us. This A, B, C, D. This is a cyclic quadrilateral. Cyclic quadrilateral, it means this circle we are talking about from B, C, D and this circle we are saying. It is lying on this circle. Then a circle passing through O, A and B, we are saying. There is another circle which passes through A and B. This circle we are talking about. This is the circle passing through A and B. It meets AD at the point E and it meets BC at the point F. It meets this at the point F. Then we have to prove that the line we obtain over here, this line EF and this line DC, both these lines, these are parallel to each other. We have named these angles as angle 1, this angle as angle 1, 2 and 3. Now as A, B, C, D is a cyclic quadrilateral, so we have angle 1 plus angle 3. We are talking about angle 1 plus angle 3, that will be equal to 180 degree. Similarly, this BFEA is a cyclic quadrilateral, so this angle 1 and angle 2, the sum of these two angles is also 180 degree. Now if we equate these two equations, both these values is 180 degree, we get that angle 2 is equal to angle 3. Now look at these two lines over here. This is the line EF and this is the line DC. For these two lines, we are talking about AED as the transversal line, and what we have is that this angle 2 and this angle 3, both these angles, these are equal. So it means both these lines will be parallel to each other, and this is what we have to prove. Now next in this figure, it is given that A, B, C and D, E, F, these are the two pairs of collinear points. Collinear point means A, B, C and D, E, F, these are the straight lines. Further, we have circles over here where on which these points, these are line, that is A, B, E, D is a cyclic quadrilateral and B, E, F, C is a cyclic quadrilateral. Now we have to prove that AD, this AD and CF, these two lines, these are parallel to each other. Now we are talking about ABED quadrilateral. It is ABED. We are talking about this quadrilateral over here. This is cyclic quadrilateral. So what we have is that sum of angle 1 and angle 2, that is equal to 180 degrees. Again, if we look at B, C, F, E, we are talking about this quadrilateral over here. We are saying this angle 2 is the exterior angle for this quadrilateral. This is a cyclic quadrilateral and this is the exterior angle over here. So what we get is angle 2 and angle 3. These will be equal to each other. So we get that angle 2 is equal to angle 3. So from these two results, we can write angle 1 plus angle 3 is equal to 180 degree. Look at these two lines. This is line AD. This is line CF. We are talking about, this is the transversal over here, and angle 1 plus angle 3, the sum of these two angles is 180 degree. It means both these lines, these are parallel to each other. Next we are given two circles and they are intersecting at the points P and Q. So we are given this angle at A is 80 degree, this angle at D is 84 degrees. We have to calculate the value of angles at this point B and C. So when we are looking at this quadrilateral AQD, QPD, this is a cyclic quadrilateral, and this angle at A is 80 degree, then this angle at P will be, this angle at P, we are calculating over here in the second figure, we are saying this angle will be 100 minus 80, with 180 minus 80, that is equal to 100 degree, and this angle at Q will be 180 minus 84, that is equal to 96 degrees. Now look at this quadrilateral QBCP. This is also a cyclic quadrilateral, and this AQ and DP, if we look at, so this DBQ side, this is extended to QA, this CP side, this is extended to PD. So this is the exterior angle, this angle we have marked over here, this is the exterior angle, and the interior opposite angle will be angle at B. So angle at B will be 100 degrees. For this angle at Q, this angle at Q, this angle at C is the interior opposite angle, and the value of this angle will be 96 degrees, and these are the two angles that we have to calculate. In this question we are given two circles, they are intersecting with each other. This is one circle and this is the second circle. These two circles, these are intersecting with each other at the points A and B. The center of the smaller circle O, it lies on the larger circle. Now if angle PAC, this PAC is the straight line we are saying, it is not angle, and this PBD, this is also a straight line, and angle APB, we are talking about this angle over here, this is APB, this angle is 70 degrees, then we have to find angle AOB. So we are saying this angle APB is 70 degrees. O is the center of, we are talking about this smaller circle over here. Now in this circle, this is the center and this is the angle at the, on the circle. So look at this arc AB over here. So for corresponding to this arc, this is the angle at the center. So its value will be double of this angle. So that will be 140 degrees. Next, look at this quadrilateral over here, cyclic quadrilateral CA. We are talking about O and B. This quadrilateral we are talking about, it is CAOB quadrilateral. In this quadrilateral, we are saying this angle over at O, it is 140 degree, and this angle at C will be, the sum of both these angles will be 180. So this angle at C will be 180 minus 140, that will be equal to 40 degrees. Now if you look at this angle at C, this angle at C, that is ACB we are talking about, this is on the arc AB, this angle is on the arc AB, and on the same arc we are having this angle ADB. So it means this angle at ADB over here, this angle over here, this is also of measure 40 degrees. So these are the three angles that we have to calculate. This angle at O is 140 degree, this angle at C is 40 degree, and this angle at D is 40 degrees. Now in this question we are given a triangle ABC, and it is given that it is an isosceles triangle, and this side AB and AC, these are equal to each other, and D and E, these are the midpoints of the sides AB and AC respectively. So we have DE is parallel to BC. Now what we have is, the first thing we get from this is that if this angle is X, then the value of this angle is also X. Now D and E, these are the midpoints of side AB and AC. So what we have is that this DE and BC, these two are parallel by midpoint theorem. It means this angle at X, if this angle at B is X, then this angle at D over here it is X, and this angle at E over here, it is also x degrees. Now we look at this angle at E over here. We are talking about this point E. Now what is the value of this remaining angle over here? It is 180 degree minus x. This is the value of the angle at E. Now what we get from this is, look at these two angles. This angle at E, it is 180 minus x, and this angle at B, this is x degrees. So sum of both these angles, it is x degree plus 180 degree minus x, that is equal to 180 degree. So what we get is, if we look at this quadrilateral D, B, C, E over here, we look at this quadrilateral over here. So we have sum of this angle B and E, opposite angles, is 180 degree. It means this DECB is a cyclic quadrilateral, and that means that these points B, C, E, D, they lie on a circle. They are concyclic. In this question, we are saying that we have to prove that the bisector of any angle of a triangle and the perpendicular bisector of its opposite side intersect. Then they will intersect on the circumcircle of the triangle. So we are saying a triangle ABC is given to us. Then one thing that is given to us is this AD is the angle bisector, and this OE is the perpendicular bisector. Perpendicular bisector means this is perpendicular and these two are equal, and this is angle bisector means these two angles, these are equal to each other. We have to prove that if these two AD and EDE we are talking about, if these two intersect, they are intersecting at some point D, and this D will lie on the circumcircle. Circumcircle means we are talking about a circle which is passing through the points A, B and C. We are saying that this point D will lie on this circle. So first of all, we have done the construction over here, and we have joined these points B, O and CO. We have joined the points B and C with the center O. Now look at this triangle over here. This point, we are saying this point is E. This angle is 90 degrees. These two are the radius, and this is the common side over here. So if we look at these two triangles, one is OBE and second triangle we are talking about is OCE. We are talking about these two triangles. We are saying both these triangles, these are congruent to each other. Now if these two triangles, this is by these two sides, these are equal, this is common side and this angle is 90 degrees. So what we get from this is that this angle at O, these two angles we are talking about, that is BOE and EOC, both these angles, these are equal to each other. Suppose their value is x and x. Now look at this arc over here. First we are talking about this arc BD, and second we are talking about this arc DC. So when we are talking about this arc BD, we are having this angle at O is this angle at A. So the value of this angle at x, it is x by 2. Next we are saying, we are talking about this angle at D. This is DOC. We are talking about this angle DAC. The value of this angle will be x by 2. What we are saying is, we are trying to prove this thing. We are not considering that this angle at A is the angle bisector earlier. We are just talking about that we have considered OD is the perpendicular bisector. This OD is the perpendicular bisector. We have joined this point D and A, and what we have obtained is that this DA, this line DA over here, this line AD we are talking about, this line is the angle bisector. And this is what we have to prove, that we are saying that the angle bisector of this angle A, it passes through the point D. That is, it meets the perpendicular bisector OE at the point D, which lies on the circumcircle of the triangle ABC. Now in this next question we are given that this AB is the diameter of the circle with center at O. This O is the center over here and this is the diameter of the circle. If ADE, we are talking about this angle ADE, this is a straight line, and CBE is a straight line. At this point E over here, this angle is 25 degree, and at A this angle is 35 degree. So if we look at this triangle over here, this angle at D at this point, this angle is 90 degree, then this angle is also 90 degree. In this triangle DBE we are talking about, we are having this angle at B, this will be 90 minus 25, that is equal to 65 degrees. If this angle is 65 degrees, it means the value of this angle over here at B, this will be 180 minus 65 degree, that is equal to 115 degrees. So this is our angle DBC. This is the first part that we have to find, DBC. So this angle is 115 degrees. Next, if we look at this arc BD over here, this arc BD over here, we are talking about one angle is BAD and second angle is BCD. Both these are on this arc and this angle will be 35 degrees. Now this is the angle BCD, second angle we have to calculate, and third we are talking about the angle CDB. So we are saying this angle is 35 degree, this angle we have calculated, this is 115 degree. So the value of this angle will be 180 minus 115 minus 35 degree, and the answer we will get it is 30 degrees. So these are the angles that we have to calculate in this question. In this question we are given an angle ABC. This is the angle ABC we are talking about, and this point B is lying outside a circle, and it is given that these chords AD and CE, both these chords, these are equal in length. Then we have to prove that angle ABC is equal to half of the difference of the angle subtended by the chords AC. This is the chord AC, this is the chord DE. These are the two chords we are talking about. We have to prove that the angle subtended by these chords at the center, this angle at B, is half the difference of these two angles over here. So to prove this, we are starting this problem by considering two triangles. One is OAD. We are talking about this triangle OAD, and second we are considering the triangle OCE. We are considering these two triangles. So in these two triangles we are saying that these are the radius over here, and these two sides, these are given to be equal. It is given that the chord AD and CE, these are equal to each other. So if these two are the radius over here, we are saying suppose this angle is x, then the value of this angle is also x. Next we have these two triangles, these are congruent to each other. It means these angles over here, these are also equal to x degrees. Now similarly, if we consider the triangles, we are talking about the triangle OED and the triangle OAC. Now in these two triangles we are saying the side OA, this side we are talking about OA, and OC, these are equal. So it means these two angles, these are equal to y degrees. Similarly OE and OD, these are equal. It means these two angles, these are equal to z degrees. So the value of the angles at the center over here, what is the value of this angle over here? It will be 180 minus 2y. What is the value of this angle over here? It is 180 minus 2z. These are the angles over here. Now as ACED is a cyclic quadrilateral and this angle at E is x plus z, this angle at A is x plus y. So total angle over here, this is 2x plus y plus z, that is equal to 180 degree. This total angle is x plus y, this total angle is x plus z. So total angle over here, it is 2x plus y plus z is equal to 180 degree. Now if we look at this triangle BDE, we are talking about this triangle BDE. In this triangle, we are having this angle at D. This is equal to 180 minus x plus z. This angle is equal to 180 minus x plus z. So the value of angle at B, that is 180 minus 180 plus x plus z, then it is minus 180 plus x plus z. So these two 180 gets cancelled. So the angle at B will be, this angle at B will be 2x plus 2z minus 180 degrees. Now we have two equations over here. One is this equation, that is 2x plus y plus z is equal to 180, and this equation gives us 2x is equal to 180 minus y minus z, and second, this value of this angle we are having over here, it is 2x plus 2z minus 180. So if we substitute the value of 2x over here, we get that the value of this angle is, it is 180 minus y minus z plus 2z minus 180. These two 180 gets cancelled and we are left with z minus y. So finally what we have is this angle at B over here, it is z minus y, and if we find the difference of the angle subtended by the chords AC and DE at the center, then the angles we have, this angle is 180 minus 2y, and this angle we have, it is 180 minus 2z. So difference of these two angles will be 180 minus 2y minus 180 plus 2z. So this gets cancelled and we are left with 2z minus 2y, that is equal to 2 times z minus y. And this is what we have to prove, that this angle at B, it is z minus y, and difference of these two angles is 2 times z minus y. And this is what we have to prove, that the angle ABC is equal to half of the difference of the angle subtended by the chords AC and DE at the center. Now next we have to prove that if any regular pentagon is given to us, then if we consider any four vertices, then they are concyclic. So suppose ABCD is the regular pentagon that is given to us, and first we are proving that the points A, B, C, E, they are concyclic. So to prove this, we have done the construction over here, that we have joined A, C and B, E. Now look at the triangles over here. First we are talking about the triangle ABC, and we are talking about the triangle BAE. These two triangles we are talking about. So in these two triangles, we are saying that this side AB is the common side. Then we have BC, this side BC, and this side AE. These are equal to each other. And then we are saying that the angle ABC, this angle over here, and the angle BAE, this angle over here, both these angles, these are equal to each other and they will be equal to 108 degree because it is a regular pentagon. So both these angles, these are 108 degrees. So it means both these triangles, these are congruent to each other by SAS axiom. So what we get is that this angle BCA, this angle BCA and the angle BEA, both these angles, these are equal to each other by CPCT. So what we have is that AB subtend equal angle at 2 points C and E on the same side of AB. So what we get is that ABCE are concyclic. This result we have already seen. We are saying that we can find a circle over here. We are talking about, we can find a circle over here which is passing, for which AB is a chord and this C and E, they are subtending equal angles, so they lie on the circle over here. So what we get is that A, B, C, E, they lie on a circle. So these 4 points, these are concyclic. Similarly, we can consider any other 4 points and we can prove that those 4 points, they are also concyclic on the regular pentagon. Now next we have some theorems related to cyclic quadrilateral. So first is prove that every cyclic parallelogram is a rectangle. So we are saying that a parallelogram ABCD is given to us. Parallelogram means the opposite sides, they are parallel to each other, and further it is given that ABCD, they all lie on a circle. These 4 points, these are concyclic. So what we have over here is, if these are concyclic or this is a cyclic parallelogram, then the sum of these two angles will be 180 degree, and we know that in a parallelogram opposite angle they are equal. So both these are x. So what we get is 2x is equal to 180. So value of x you will get it is 90 degree. So what we get is that it is a parallelogram whose these angles are of 90 degree measure, and a parallelogram whose angles are of 90 degree is a rectangle. Now next we have to prove that an isosceles trapezium is always cyclic. So we are saying an isosceles trapezium is given to us. Isosceles trapezium means we are talking about this side AD and this side BC. These two sides are equal to each other. Then we have to prove that this trapezium is cyclic, that is a circle is there which passes through the point A, B, C and D. So to prove this, we have to prove that the sum of these opposite angles A and C, sum of these two angles, and sum of the angle B and D, sum of these two angles, it is 180 degrees. Now if we look at these two sides, it is a trapezium over here. So we are saying that this A, B and C, D, these are parallel to each other. So we have done the construction over here that we have drawn DL perpendicular on AB and this CM perpendicular on AB from the point D and C respectively. So in the right angle triangles, we are talking about this DAL and this CMB. These two triangles we are talking about. This AD side and this CD side, these are equal to each other. These angles over here, these are of 90 degrees. Both these angles, these are of 90 degrees. And we know that the distance, these two lines, these are parallel to each other. It means that this distance DL, that will be equal to the distance CM. These two distances DL and CM, these are also equal to each other. So what we get is that both these triangles, these are congruent to each other by RHS congruence criteria. So this thing gives us that angle A and angle B, both these angles, these are equal to each other by CPCT. These angles, these are equal to each other by CPCT. Now these angles at D over here, these are also 90 degree. This angle at D over here is 90 degree. This angle at C over here, it is, these two angles, these are 90 degrees angle, because the line, if we talk about CD and AB, these are parallel. So we look at these two lines, one is this DC and one is this line AB. and we are talking about the transversal DL and transversal CM, then these are supplementary angles. So angle at D will be 90 degrees. Now if the value of the angles over here at A is X, value of angle at B is X, then the value of over here at angle C, it will be 90 minus X, and this angle will be 90 minus X, because this angle at L over here, at this point L the angle is 90 degree, at this point M the angle is 90 degree. So this angle at D is 90 minus X, and this angle is 90 minus X. So this total angle over here at C, this angle at C over here, and this angle at D over here, we are saying this total angle over here, this will be, this angle will be, this total angle we are talking about, this will be 90 plus 90 minus X, that is equal to 180 minus X, which is equal to this angle at C. Now if we find the value of the angle at D plus angle at B, so angle at D is 180 minus X and angle at B is X, so total angle we have it is 180 degrees. Similarly angle at C plus angle at A, that is 180 minus X plus X, that is equal to 180 degrees. So both these angles, these are equal to 180 degrees. So this is, we have proved that an isosceles trapezium is always cyclic. Why? Because the sum of this angle A and C, sum of angle B and D, they are equal and equal to 180 degrees. In this question we have to prove that a cyclic trapezium is always isosceles. So we are saying a trapezium is given to us and it is given that it is a cyclic trapezium. So if this is a trapezium, it means we are given that this side CD and this side AB, these are parallel to each other, and further it is given that this the vertices A, B, C, D, they lie on a circle. These vertices, they lie on a circle over here. This is A, B, C and D point. So if we look at this, we are going to do some construction over here, and we have joined these points A, C and B, D. So if we look at these two lines over here, we are saying A, B, this is parallel to C, D. So what we get is that the sum of angle, this angle and this angle, sum of these two angles, their sum is 180 degree. Similarly, sum of angle at C and sum of angle at B, sum is 180 degree. Now next we are talking about two triangles over here. One is the triangle ADC and second triangle we are talking about is triangle ACD. So in these two triangles we are saying this side AD, these are the common sides. Then we have this angle at D and this angle at C. So again we look at our this triangle, second triangle. We are saying if this angle is X, then the value of this angle is 180 minus X, and as the triangle, this trapezium that is given to us, this is cyclic trapezium, so the value of this angle is also 180 minus X. So it means that angle at D and angle at C, the value of angle is 180 minus X. Both angle they are same, their values is 180 minus X. So it means these angle D and C, these are equal to each other. We are saying this angle at D and this angle at C, these are equal to each other. And then the next thing that we have is that the angle DAC, this is angle DAC, and the angle DBC, they both lie on this segment CD. So it means both these angles over here, both these angles, these are also equal to each other. So what we get is both these triangles, these two triangles, these are congruent to each other. So we get that this side AD and this side BC, these are equal to each other. Then we have this side AC and this side BD, these are equal to each other. So this thing proves that the cyclic trapezium, the trapezium that was given to us, that was a cyclic trapezium, it is always isosceles. Isosceles means we are talking about this side AD and this BC, they are equal to each other. And second thing we have is diagonals are equal, because AC and BD, they are also equal. Next we are given a cyclic quadrilateral ABCD. This ABCD is a cyclic quadrilateral, and the angle bisectors of the sides are given. Angle bisector of A is AP, angle bisector of D is DR, angle bisector of C is RC, and angle bisector of B is BP. These are the angle bisector that is given to us, and we are now left with this quadrilateral QRSP over here, this quadrilateral. So we are saying this quadrilateral is also, we have to prove that this quadrilateral is also a cyclic quadrilateral. So if we look at the triangle ABP, this triangle we are talking about ABP, and second triangle we are talking about is DCR. These are the two triangles we are talking about. So sum of these angles, sum of their angles is 180 degrees. So sum of their angle means if we are talking about this angle APB, suppose this is X, then we have the angle PAB, we are saying this is Y, and this angle is Z. Similarly we are saying this angle is A, this angle is B, and this angle is C. So we have X plus Y plus Z equal to 180 degrees. Similarly we have A plus B plus C is equal to 180 degree. Now if this angle is Y, this whole angle is 2Y, this whole angle is 2Z, this whole angle is 2B, and this whole angle is 2A. Now what we have is 2Y plus 2B, that is equal to 180 degree, and 2A plus 2Z, that is equal to 180 degree, or we can say it is 2 times A plus B plus Y plus Z is equal to 360 degree. So we get A plus B plus Y plus Z equal to 180 degree. These are the two equations that we have now, that is X plus Y plus Z is equal to 180 and A plus B plus C is equal to 180. If we add these two equations, we get it is X plus Y plus Z plus A plus B plus C equal to 180 plus 180. Now what is value of A plus B plus Y plus Z? The value of this portion over here, it is 180 degree. So what we are left with is that X plus C is equal to 180 degree. So angle X plus angle C is equal to 180 degree. Now we have this PQRS is a quadrilateral, so it means sum of these two angles, sum of these two angles at Q and S is also, sum is 180 degree. So this proves that this PQRS is a cyclic quadrilateral. Now in this question we have to prove that the sum of the angles in the 4 segments exterior to a cyclic quadrilateral are equal to 6 right angles. So we are saying we are given a cyclic quadrilateral A, B, C and D. This is the cyclic quadrilateral. Now 4 segments we have, it is AB, BC, CD and DA. Now the exterior angle formed over here corresponding to this is BQC, corresponding to second it is CRD, next it is DSA, and next it is APB. So we have to prove that the sum of these angles R, S, P and Q, sum of these 4 angles is 6 times 90 degrees. This thing we have to prove. 6 times 90 degree means we have to prove that their sum is 540 degrees. So to prove this, we have done the construction over here, and we have joined the point C with S, and we have joined the point B with S. Now look at the quadrilateral over here. We are talking about the quadrilateral APBS. We are talking about this quadrilateral over here. So in this quadrilateral, we are saying that if this angle is angle 1, and we are talking about this opposite angle P over here, this is the angle P over here, we are saying that the sum of angle 1 and angle P will be 180 degree because it is a cyclic quadrilateral. Now consider the cyclic quadrilateral S, B, Q and C. We are talking about this quadrilateral over here. Now this angle 2 and angle Q, these are the opposite angles over here. So we have angle 2 plus angle Q, that is equal to 180 degrees. Now the third quadrilateral we are considering in this case, it is quadrilateral S, C, R and D. This quadrilateral we are talking about. So in this quadrilateral, we are saying this angle 3 and angle at R, these are equal to each other. So we get that angle 3 plus angle R, that is equal to 180 degree. So we have three equations over here. This is equation number 1, equation number 2 and equation number 3. If we add all these three equations, we get the equation in the form that angle 1 plus angle 2 plus angle 3 plus angle P plus Q plus R, that is equal to 540 degree. Now look at this angle over here, angle 1 plus angle 2 plus angle 3. This whole angle is basically the angle, this whole angle, it is the angle S. So we get that the sum of all these four angles is equal to 540 degree, and 540 degree means it is 6 times the 90 degrees, that is 6 times the right angles. Now in this next question, we have to prove that the altitudes of a triangle, they are concurrent. So we are saying a triangle ABC is given to us, and the altitudes are given. This CF is altitude over here, and this BE is the altitude over here. Altitude means these angles over here, these are 90 degree angles. So we have to prove that this AD, that is this line that is passing through the intersection of these two, this is also this line AD is also the altitude. Altitude means that we have to prove that this angle is 90 degrees. So to prove this, we are going to do the construction over here that we have joined these 2 points F and E. We have joined these 2 points F and E. Now if we look at these angles over here, one we are talking about BEC, and second angle we are talking about is BFC. We are talking about these 2 angles over here. So both these angles at this point, they are of 90 degrees. It means they are equal. And we know that if this line BC we are talking about, and these 2 angles, these are equal, it means BCEF is a cyclic quadrilateral. If it is a cyclic quadrilateral, so we get that ECB, we are talking about this whole angle over here, this is angle ECB plus angle BFE, this angle over here BFE, sum of these 2 angles is 180 degree. Sum is 180 degree. Now what we have is that this angle at F, this angle is 90 degree. If this angle is 90 degree, so we are talking about, I'm talking about this equation over here. We have written that angle ECB plus BFE, that is equal to 180 degree. This ECB, we can write it like ACB. We are writing ECB as ACB. And this BFE angle we are talking about, this is the angle BFE. This point we are talking about BFE. This is made up of 2 angles. One is BFC. This is BFC. And second angle we have is CFE. So we have written it in this form that it is BFE, that is equal to BFO plus OFE. And this angle we know the value of this angle is 90 degree. So we get that angle ACD plus angle OFE, that is ACD. This whole angle we are talking over here, this angle ACD plus angle OFE. This angle we are saying the sum of these two angles, it is 180 degrees. Not 180 degree, but it is 90 degrees. So we have this equation over here. The first equation we are talking about, that angle ACD. At this point we are saying this is the angle ACD, and plus angle OFE. OFE is this angle we are talking about. The sum of these two angles is 90 degree. Again, if we are talking about OFA, we are talking about this angle OFA. This is OFA we are saying, plus OEA. These two angles we are talking about. So their value is 90 degree plus 90 degree, that is equal to 180 degree. Why? Because if we look at this second figure over here, I am talking about this region. We are saying this angle is 90 degree. So this remaining angle over here, this will be 90 degree. Similarly, this angle is 90 degree. So this remaining angle over here, this is also 90 degrees. So what we get from this is that this EOFA, this is also a cyclic quadrilateral. Now, if we look at the angle OFE, we come to the next diagram. We are the same diagram is there in this next slide. We are saying we are talking about the angle OFE, that is equal to the angle OAE. This angle will be equal to angle OAE. Why? Because if it is a cyclic quadrilateral, then we have a circle over here which passes through these points. We are having a circle over here which passes through the points A, F, O and E. Now look at this segment OE over here. So on this segment we are having this angle at A and we are having this angle at F, and both these angles they will be equal. Both these angles they are equal. Now from the result 1 and from the result 2, we are saying the result 1 is that angle ACD plus angle OFE, that is equal to 90 degree, and the result 2 is that angle OFE, that is equal to angle OAE. We are getting that angle ACD plus angle OAE, that is equal to, we have just replaced this value over here and we are getting the answer is 90 degrees. So this gives us that angle ACD is this angle over here, and angle DAC is this angle over here. So sum of both these angles is, we are having it is 90 degree. Now we know that the sum of the angles of the triangle is, we are talking about this triangle ADC. What we have proved is that the sum of these two angles, their sum is 90 degree. So if we look at this triangle over here, it means this angle at D is 90 degree. So this means that AD is perpendicular to BC, and this is what we have to prove, that AD is the altitude of the triangle ABC on the side BC, and it passes through O. So we have three altitudes over here. One is this altitude AD, second is the altitude BE, and third altitude we have it is CF, and all these three altitudes they pass through this point O. So we are saying that all the altitudes of this triangle they are concurrent.